Okay, so continuing on with surface area, we are going to do surface area of pyramids. So let's talk about the difference between a prism and a pyramid, because we just spent an entire day working on surface area of prisms. Okay, this would be a square prism. Okay, obviously I've used this block for other stuff, so kind of ignore the writings on it, but it's a square prism. Remember, it has two bases. Okay, on a square prism it doesn't matter which ones you call the bases, but we can call that one the base, and we can call that one the base, the one that's empty. Okay, and that would make the other ones the lateral faces. Okay, and remember the height, I'm going to use this spaghetti stick as the height. The height is the distance between the bases. Now let's look at a pyramid. Here's a pyramid. It's a square pyramid. Okay, because the base is a square. So you always name a pyramid according to its base. If the base is a triangle, it would be a triangular pyramid. If the base is a pentagon, it would be a pentagonal pyramid. Okay. Notice what shape the lateral faces are. Are they rectangles anymore? No, they're triangles. Okay, so in this case, our lateral faces are triangles. Something else you should notice is the number of bases. When we had a prism, we had two bases. When we have a pyramid, how many bases do we have? Just one. Okay, so that's a couple of the differences between prisms and pyramids, is the lateral faces are rectangles. Okay, and there's only one base. Okay. Another major thing with pyramids is there are two different types of height. Okay, and we're going to write this down in just a second, but let's just talk for a little bit. There are two different types of height. Normally you think the height of something as the tallest point straight down perpendicular. So I'm going to show you what the height of the pyramid would be. Okay, so the height of the pyramid is this piece of spaghetti stick. As you can see, it goes from the vertex straight down to the middle of the base. That would be the height. But we have something else. If I take that bottom part out, okay, there's another type of height useful, especially for doing surface area, and that's called the slant height. Okay, the slant height does not go to the middle of the base. The slant height goes to the middle of one of the sides. It's actually the height of one of the triangles is what it is. And we call that a slant height because if you look at it straight on, it is, get this rotated the right way, it is slanted. Okay, it doesn't go straight down. Remember, this is regular height. This is slant height. Okay? Alright, so that's just some observations. Let's write down some of that information. Okay, to draw a pyramid, okay, a square pyramid, you're going to draw a parallelogram, because remember, anytime you're drawing three-dimensionally, whatever the base is, you kind of draw it so that it's squished down. So draw a squished square. Okay, then you're going to put a point up at the top, and you're just going to connect all of the corners. Okay, so that is a pyramid. Okay, we have the base, which again is not always on bottom. Okay, you might see a pyramid sideways, you can see a pyramid upside down. The base is not always going to be on bottom, so how do you identify the base? Okay, it's the non-triangle. And if it's a triangular prism, or pyramid I mean, it depends. If one of the triangles is different than the other ones, the other three, then the one that's different is going to be your base. It's possible for all of them to be equal, in which case you could pick any of them as your base. Okay, so we'll say non-triangle, non-congruent triangle. Okay. Just in case they're all triangles. All right. These are your lateral faces. Okay. And again, we have two different kinds of height. Okay. We have the regular height we have the slant height, which is still perpendicular to the edge. So this one's perpendicular to the plane, to the base at the bottom. This one's perpendicular to the edge. Okay. So again, we have height, which we call h, from vertex perpendicular to the base, and we have slant height, which they use L, they use a cursive L to identify slant height. They can't use H because H is already taken. The reason why they use L, I'm guessing, is because of the L in the word slant. They can't use S because S is most commonly used for a side length. So they didn't use S, so they picked to use L since it's the second letter. Okay, and this is from vertex, okay, perpendicular to the edge of the base. So this one goes to the middle, this one goes to the edge. Another thing I talked about is we have triangles, lateral faces, remember? Okay. So, one thing that's going to be really important in this lesson is we're going to use slant height in this lesson. For surface area, it's slant height. For volume, we're going to go back using height. Okay, that's why it's important to know both of them. It's also important how to know to go back and forth between them. If they give you the height and you need the slant height, or if they give you the slant height and you need the height, there's a real easy way to find it. You can use the Pythagorean theorem to go back and forth between your two heights. Okay, so if you have one and need the other, you can just use the Pythagorean theorem, because if you look right there, okay, there will always be a right triangle. Okay, again, I'll show it to you on here. Where'd my spaghetti go? There it is. Okay, so let me show you this right triangle again. Okay, put the thing back on. Alright, so if this line represents the slant height, and I put my regular height in the middle, and I turn it this way, do you see how the height and the slant height make a right triangle with the base? Okay, it is this, and I'll do it with my left hand, this triangle down, over, and then up. Okay, that makes a right triangle, so you should be able to use the Pythagorean theorem. You'll see an example in the first example. Alright, so the formula, lateral area is 1/2 PL. P still stands for perimeter, and remember L stands for slant height. And then the surface area is the lateral area plus, except this time, how many bases were there? Were there two bases or were there just one? In this case, there's just one base. So we're only going to add one of the bases. We don't have to double the base this time. Alright, an example. We'll keep going with square pyramid for now. And we'll give you some harder ones in just a second. Okay. Alright, so if I tell you that the height is 6, and one of the sides of the square is 4, and I want the surface area. Okay, so everything we need P, L, and B. So let's list those out. We need P, L, and B. P stands for perimeter of the base. So 4, 4, 4, 4 equals 16. L stands for slant height. Again, remember, we're going to use this right triangle right here. Okay? Where's my green marker. Okay, this is the right triangle we're going to use. Okay, we know this is 6, and this length is actually going to be 2, because if the whole length is 4, then that's half, so that's 2. So 6 squared plus 2 squared equals L squared. That's 36 and 4, which is 40. So L equals the square root of 40, which is 6.32. Okay. And then our big B, remember, is not 4. Remember, big B is a shape. It's a square. The area of the square is 4 times 4, which is 16. So now we can plug into our lateral area, which is 1/2 P times L. And if we want surface area, we just do that again. And then plus one of the bases. Okay. That gives me 66.56, and the lateral area, I don't think I had the lateral area written down last year. I believe it would be 50.56. Okay? Let's do another one. Okay, so that was pretty straightforward. Let's do one that's a little harder, but this one you don't have to do the Pythagorean theorem on. We're going to do a hexagonal pyramid. So to draw a hexagonal pyramid, the base is a hexagon, but you're not going to draw it normal. You're going to draw it like it's been squished down. Okay, so the easiest thing to do is to draw a line there, drop down 2, draw a line, connect them here, and connect them here. So it's kind of like a hexagon that's been squished down flat. Okay, and then again, put a point at the top. Connect all the sides. Alright, so that's my hexagonal pyramid. And this time I'm going to give you the slant height is 9, and this is 6. Okay. So again, we need our P, we need our L, and we need our B. Perimeter, 6 plus 6, 6 plus 6, 6 plus 6 is equal to 36. It's just the perimeter around the base. The L in this case is given. Okay, so that's one thing you have to understand when you're doing these two sections, is how to know when it's given and how to know when when you're going to have to use Pythagorean theorem to find it. This one gave you the slant height, so it's 9. The big B is the hard part on this one. In the previous example, the L was the hardest part of the problem. In this case, the big B is the hardest part of the problem. Remember, the area of a regular polygon is 1/2 AP. So we are going to have to find that apothem. This is 6. There's my apothem. There's my triangle. If this is 6, this is 3. Remember, a hexagon, this angle is always 30, which makes it a special right triangle. So to go from short to long, it's just 3 times square root 3. So my apothem is 3 square root 3. Again, my perimeter is still 36. And so now I can plug into this formula. 1/2 3 square root 3 times 36. And that gives you 93.5. So now we can plug into our surface area formula. 1/2 PL plus B. So 1/2, 36, 9 plus 93.5. I didn't write down what that gave me last year. Hold on. Let me move it over so you can see it. 5 36 times 9 plus 93.5. 2255.5. One more quick example. Just like yesterday, you do have a formula in your book for a cone. But really, a cone is just a pyramid with a circular base. So you can continue to use this formula if you want to. And I would suggest it because it's less formulas to remember. Okay? Alright. Okay. So again, my P, my L, and my B. Now, P stands for perimeter of the base. Remember, perimeter of the base, if it's a circle, is the same thing as circumference. Okay, so D pi, which is 6 pi. Again, I don't know what my slant height is. I'm going to have to use, and you can actually see the right triangle a little bit better in a cone. Here is that right triangle we're using. And it works for the regular pyramids as well. Okay, but this is the right triangle. So it's a right triangle. This is 8 and this is 3. So it's 8 squared plus 3 squared equals L squared. That's 73 equals L squared. So L equals the square root of 73. To 8.54. Okay. And the big B stands for the base, so that's pi r squared, which is pi 3 squared. Remember the radius is 3 here, okay, which is 9 pi. Now I can do surface area. 1/2 PL plus B. So 1/2, perimeter is 6 pi, and L is, and I can leave that as square root of 73. Remember, I've tried to train y'all all year to leave it in the simple form. Don't put it in decimal until the very end, because your calculator will handle all of this stuff for you. And then you'll have a more accurate answer. So 0.5 times 6 pi times square root of 73 plus 9 pi. And just for those that are curious of how I'm typing this in, okay, as you can see, I changed the 1/2 to 0.5 because it's just easier. I put the 6 pi in parentheses. I did the square root of 73. Notice my square root symbol stops after the 3, and then I do plus 9 pi. It gives me 108.8. And that's it.